All right, folks, if we could grab our seats. We've got the next group coming up. And Dave Elder will introduce them as well.
Okay, I'd like to introduce Mikhail Tenikoff and Ryan Hubbard, talk to you about their senior project.
Thank you, Mr. Eller. As he mentioned, my name is Ryan Hubbard,
My name is Mikhail Tennikov.
and we did our project over a card access system for the AEC. AEC stands for Applied Engineering Center. It's located here on USI's campus. It has 45 various different machines that all need access control installed. Right now, the current problem with the equipment at the AC is everyone has access to it. That poses a couple different problems. Obviously, someone could get hurt if they don't know how to use the equipment, or the equipment could become damaged. We would like to be able to monitor who uses the equipment and also track the equipment usage for maintenance.
So basically, to solve these problems, we decided to go with some kind of card access system. And since these machines they require some high training and safety, we would restrict access to each machine, and this would prevent the students from who are not authorized to use the machines.
This is an equipment list that we generated for each, well, we have 45 machines, but these are some of the main ones. It lists the model, the description, the SN, and also what kind of wiring type, which becomes important later. We'll mention whether it's a direct cord or an emergency stop. With this list, we then generated an AutoCAD design layout of the shop floor, and we assigned locations. That way you can kind of view where the machines are at and all the information that deals with that machine. Back at the office, you don't have to be out on the shop floor.
We basically separated all the machines into two different categories of power sources, which is the control panel. It's basically more sophisticated equipment that has e-stops and direct wire control. Basically, that's less sophisticated equipment, like the manual drills. All it requires is just a cord from the power source to operate the machine. This is a basic diagram how we're planning to install the card readers. And this picture here is basically an normally open switch card reader with a normally open relay. Basically how it would work, it would be installed between the power source and the equipment. And whenever the authorized user presents their card, the circuit would close and allow the current to flow to the equipment. This next one is very similar, but for the e-stops, we would wire the card. It's also a normally open card reader. We'd wire that in series with the e-stop, and all of that is done inside the actual control panel. So it's not going to be, the wires are not going to be hanging out outside the control panel anywhere. And all the card readers would obviously be placed somewhere in an easy accessible location, typically on a location somewhere on the control panel.
With this information and being prepared, also by using AutoCAD and the exact locations of the machines, we were able to map out exactly how many feet of wire and conduit and everything else we would need. We used RS Means estimation book to come up with our costs. This doesn't include high voltage control panels or any of the hardware that's associated. This is just the wiring and conduit alone if we went with the wired option. And it comes out to about $13,300. So once we got our estimate, we felt comfortable to go ahead and contact people for possible proposals. The first company we contacted specializes in this exact access systeming, yes. And their name is Whiting Passport. They have this blue puck that's located in the top right corner. It's referred to as the access point. It's just a little piece of wireless equipment. It can be connected to any electrical device. And it's not very big, so it's awesome.
This is a basic visual diagram of how the system works. So starting from the left here, this blue puck would be placed somewhere in the equipment, and it works through a Bluetooth signal. So it would send a signal to a site sentinel, which would be located somewhere in the building, closer to a window probably. Then the signal would go into the cellular network at the tower, and from that it would go into the secure servers at Whiting headquarters, which are located near Chicago. All of this is done almost instantaneously, so the lab manager or the admin is able to basically log in on any computer that has the software installed and monitor. They can give access to the users or print out reports, and there's a lot more they can do with it.
Once we explored the Whiting proposal, we were able to come up with the advantages and disadvantages in our opinion, and after doing the research. First of all and foremost, the advantage with Whiting is, as I mentioned earlier, they specialize in this especially. I mean, it was invented for this reason, so their existing design is top-notch. Has instant data feedback, robust design. They're using coal mines and everywhere else, and they stand up to all the impacts and elements, so it's gonna last out there. Also too, they have a super user-friendly software. Once again, it was designed for this, so it's easy to understand. There's buttons, icons, everything. If you want to access someone to a crane, you click the crane icon, and then you can assign them access to that, or deny access if you need to do that. Some disadvantages, obviously, that nice software comes with a licensing fee each year. Possible signal losses due to Bluetooth. We all know AEC is notorious for bad signal up there. However, Whiting said that working in coal mines and stuff, there shouldn't be a problem. We would have to obviously do some testing and see how that fares out. And also too, the limited card reader design, we couldn't, with that blue puck option and it being as intelligent as it is, it's their only option that we have right now, which is just a card reading option. We couldn't go to biometrics or anything like that. We're kind of forced to stick with their blue puck design, which is still great. It's just maybe a disadvantage. Once we saw the advantages and talked to the rep of Whiting, we had them generate a quote. This isn't very detailed. They weren't too open to giving us a super detailed quote, but they gave us the hardware cost of $50,600 and the installation and administration training, which is over a 5-day period. It costs $8,200. It's basically them coming in, their technicians teaching our maintenance and everybody else how to properly install 3 or 5 of these, and then we're on our own from there, and if we need help, they're there for us. However, they do offer a full product replacement for a full 2 years, so that's great as well. If we have any problems whatsoever during installation or a year and a half after that with something, we can contact them and they'll come and support us.
The second proposal we got is from Belts. They are a local company here in Evansville, Indiana, and they basically specialize in door access control, which is the biggest problem we faced whenever doing this project. Most access control are for doors and kind of security stuff, and not many actually focus in the area we need to. But it's very flexible system to where they can incorporate it into what we're looking for. Another great thing with the system is that you can integrate video into it, so in case if you want to monitor how the students are using each machine, maybe if there is an accident, how it was caused, because visually it's always better to see and monitor. It's also possible, but it is not included in the proposal. This is a basic diagram of how it works. You have a card reader that is installed on the equipment, and we would have wires ran back to the control, access control panel. This picture right here. The access control panels would be located in a separate room, usually in a server room location. And you would run the wires from access control to the card reader and the equipment. And there's approximately 5,000 feet of wire that needs to be ran to total of the machines. You would then be able to control or monitor, give access or deny access to the machines. through a Ethernet connection between the computer, the switch, and the access control panel. Some advantages to this system is that it's installed in-house. So what I mean by that is all the control panels are installed here, and there's no signal that needs to leave this facility, like in Whiting, for example. It supports multiple readers, so in case we do want to change to a different type of reader, we can. It will be pretty simple to do it. It's very reliable wired connection. Since AEC is known for bad cellular connection or any Wi-Fi connection there, it's a good choice because it's wired. There's also local maintenance support because Pellets is located in Evansville, and would be significantly lower cost to that. It also has instant data feedback, and what I mean by that is that basically as soon as the card is swiped, the data is relayed back to the control panel, and only the administrator or lab manager can view it. Another great thing here is that we have a mobile app as well with this software, so administrators, again, they can view the reports and view the usage of each equipment. There are disadvantages, is no existing product designed for our specific needs. But as I mentioned earlier, it's a very flexible system, and it's a wired cable connection. It's also an advantage and disadvantage because of all the wiring we need to do. And because of that, there's a lot of floor modifications needs to be done because we have to lift up all those concrete panels to run the wires underneath. This is the cost estimate we got from Phelps for this wired system. It includes all the installations and hardware. Only problem that it does not include, we would need to get a special contractor who can deal with high voltage, because we have a lot of 480 volt and the 230 volt equipment. Phelps does not deal with that. From what they told me, it costs around $900 per machine. So we have about 20-something machines with high voltage. So basically, there's $50,000 plus the $900 per machine.
This is, once again, with Phelps Lock and Alarm Systems. This is our third proposal. It's a standalone proposal, which is kind of a unique twist. It's not reliant on wireless network or wired network. Basically, what we're going to use is this key panel that we have shown here. All the keys for each machine are ran off this lock that's in the bottom left there. So what would happen, authorized user would be assigned an access card. So you would be using an RFID card just to gain access to the control panel. You would swipe your card, the control panel would say, okay, Mr. Eller is logging into the control panel. And then once you pull a key for, say, machine, the Haslave 3, machine 7 or whatever, it would register, okay, he took a key for that machine. And then it would keep track of how long he had that key and whether or not he returned that key.
And I'm going to explain this simple diagram again. It's almost like the wired network, but it does not have all the control panels. You basically have this, with this system, we looked into the keys of what Phelps basically gave us the proposal for. You would install it on the equipment, and the only wires you would need is to basically the wires between the switch and the equipment and the wires to the power supply, which we would need to power the key switch somehow. And that's basically all there is.
Obviously, some advantages are the lower cost coming in with no needed wires, except for the small ones that Mikhail just mentioned. It doesn't take up very much floor space whatsoever, just that key panel that would probably be located near the offices or on the side by the PCB lab. Also too, once again, local maintenance support. They're from Evansville, not Chicago, so they could get here, excuse me, fairly quickly. And it's a reliable wired connection. I mean, it's within that control panel, and then the key block turns into a switch, and there's not very much maintenance that would be needed. Problem, no existing design. This design that we found, once again, is set up for doors. So it's for like security purposes, within like a warehouse or something, getting into certain closets or whatever. Also too, we would have to provide keys and cards rather than just cards. And Feltz, they're the only ones that can make these locks, the keys. So if we lost one, we would essentially be down. Hopefully we would have a backup one, but we would be down that key until we worked with them and got another one made. So that can be a disadvantage as well. Once we saw the advantages of this, we wanted to go ahead and get a quote of how much it would cost. They include the boxes, key switches, all the labor to install, as well as the $1,100 annual fee, just like the other products. And it comes out to a significantly lower subtotal, still pretty expensive, but it's $36,600 essentially.
There was one extra option we looked into, and it's provided by Kisi, K-I-S-I. It's a wired and wireless kind of system. Basically, it's like the RFID card access control system, but instead of the cards, it uses your cell phone, the smart cell, basically an Apple or an Android, to open or close the circuit to the equipment. Users would be given access through an email, and they would then register on Kisi application or on the website to use the equipment. It's a little, diagram is a little cut off, but it's about the same as the wired connection, because we would have to have control panels installed in the server room, and you would still have a reader that's installed in the equipment, but it would be basically, like I said, the cell phone is replacing the actual card. There's some advantages to it, is that we would not need to provide cards to students, so we eliminate that cost, and that we can use cell phones, which is, I guess, it's a pretty cool thing right now with technology. The problem we run into is that we are then cell phone dependent, so if anybody does not own a smartphone, they will not be able to use the equipment. Another problem we have is that AEC has very poor Wi-Fi and cell connection over there. So this option is basically very last resort if people need to have to use it. As well as it has, it's a wired connection, so we'd have to run all the wires. There's about 5,000 feet of wire. This is the estimate we got from them. It only has the hardware and the software license fee. We do get an educational discount with it. The totals out to $6,258, and it does not include any of their installation cost or the cost for running the wires.
With these proposals and the information and research, the information we were able to gather after we did all of our research, we created the decision matrix to generate which option would be most viable. We weighted the factors, obviously most important being safety. Also too, cost and durability are up there as well, they're important. However, our main focus is safety, whether or not, we're gonna make a difference in the AEC as far as accessibility goes or not. After running our decision matrix, it generated the totals where, of course, Whiting comes out on top, which they should since they focus directly on this, not doors. So from there, we would suggest USI campus to look into Whiting as our choice.
Some other recommendations we have is whenever the students are trained to use the equipment, they'll be trained to shut off, to program the CNC machines to shut off after the cycle is finished, or the process is finished, because some CNC equipment takes a long time to make a part, for example, or approximately what Justin told us, sometimes it takes up to 6 hours. So sometimes the equipment would have to be left overnight to run and finish the process. And the problem we run into it is that another student possibly come in and start using the equipment. So by training the students to program this equipment, it would shut off the machine so no unauthorized user could access it after it's finished. Another recommendation is for the DCB factory lab, which is located at AEC over there. It's a separate lab with, which doors are usually closed to that there, but would recommend adding a card access system to just door to that lab. Reason for that is most students who would be authorized into that lab are already trained to using the equipment in there. So it makes no sense to put cards on all of the equipment inside the lab. I'd like to thank faculty who helped us out and guided us on this project. Mr. James Wolf, Mr. Stephen Woodall, Mr. Kevin Nelson, Mr. Justin Amos. I would like to thank Dr. Zane Mitchell, the Chair of Engineering, for allowing us to work on this project. Our advisor, Dr. David Ellert, for sticking with us here and basically bearing us. And basically, the mom of the engineering department is Donna Moore. Thank you all.
Questions?
Nice job. On the Phelps standalone system, is there a restriction for which key you can take after you've opened the big door, or is it just you open the big door and all those keys are available to you?
There is, you basically, whatever you're authorized to use, the card will be programmed for that. It gives you authorization to use it, so only the keys you are authorized to use will be released, and you can take the key you need.
Yeah, it's a mechanical system within the panel itself, so it'll only unlock the certain keys that you have access to taking.
Okay. And on the Whiting data gathering system, is the cell service required to get the data up to their cloud? Is that included in your yearly licensing fee, or would that be a monthly cell phone bill on top of everything else?
It's all included in there. Basically, the Blue Box, as I explained, it's a Bluetooth connection between the Sentinel. I'm gonna go back to the slide real quick.
Yeah, I'm talking about from the Sentinel to the cell tower.
Okay, no, there's no fee over there. All the fees are included in the phone, so there's no cell phone fees.
Okay.
Very good work, guys. Can you explain again the difference between, some of the machines have e-stop circuits, and I didn't catch the part about shutting off the power, so electric grinder or something. How would you control that with these devices?
It's basic. This diagram is basically a simple diagram of how where the readers will be installed, but we need to install a basically either a relay or a switch that they would have to press on their machine that would disengage the power. So it can also be programmed to where the student swipes the card again, and it would open the circuit.
Did you come up with an approximate unit cost for a device like that?
Basically, installing this, that's what I meant by high voltage, is about $900 approximately, and that's like an estimate that we got from that Phelps gave us because they can't do it themselves, and we couldn't find somebody who could do it.
Did that fully answer your question?
Yes.
Kevin?
Молодец, товарищи.
Спасибо.
Okay. So, at one point you said present the card. When you say present the card, are we talking about waving the card, slot swiping the card, laser scanning the card? What are the options about presenting the card?
We're mostly looking into RFID, which is radio frequency identification device. So basically, it's just a swipe or a show, kind of like the Eagle Access cards at the rec. I'm not sure. Some people, it's the same technology. You lay it on there, it registers it. However, one of our options that we were talking about was maybe using the 3D printer to work with that puck and design a slip, basically a pocket. So you can, with Whiting, for instance, you can you can determine how long you have access to that machine. So if you give a swipe, you can have access for 5 minutes, or you can have access for, 5 hours. And then based off of that, we wanted to have access for, say, you only have access for 5 seconds, and then it keeps rechecking. So your card would have to be there the whole time. So we would design, whether we use our 3D printer or whatever, we can make it out of plastic, whatever you want to choose. You'd make a pocket to go around that puck. So your card would have to be there at all times. Whenever you're finished, you take your card out, it checks 5 seconds later, no one's logged in, shuts off power to the machine.
So Ryan, at one point you made reference to going to biometrics, or couldn't go to biometrics. What were you referring to with respect to biometrics?
As far as using like a thumbprint,
It's not eye scan or?
it could be. It's kind of vague, but I don't think we need to go that far into that. But yeah, like a thumbprint, same thing that's used like on smartphones, iPhone identification, or anywhere else.
All right, other questions? Okay, I've got one for you. Now, what the audience didn't get to see is the whole prototype you guys developed. And if you could, just briefly talk, because it occupied a good part of the semester, just briefly talk about the prototype you developed and the shortcomings with that prototype, and why you're leaning toward a commercialized system now.
So basically, when we started this project, I was very excited because I thought we get to build something. I went on Amazon and bought parts, or I did research of what I would need to buy to build an access control system. And I bought control panels online on Amazon, my favorite place to shop, and all the required components. And I put together a control system, and basically it's exactly the same thing as a wired connection that we showed you, except we're building it ourselves. The control panel, that's, let me go back to the picture here. Okay. So control panel here, control 4 devices, for 4 equipment, and each equipment would have a card reader. So, like I said, basically just exactly as this diagram, we would install a card reader on the machine for the equipment being used, and run all the wires. The benefit to all that is that we can build it ourselves, and we don't go by the costs from the RS needs, for example, and maintain it all from Home Depot with the wires needed, and like I said, it's significantly less, because the whole one system that was built, it would control 4 machines with 4 card readers, and the power supply required for that, it cost around $300 to $400. So I'm not including any of the switches or relays that would have to be included into the high voltage equipment, but it's still just the equipment itself. It's a significant cost to cover.
It's definitely still a viable option to do it ourselves. Once we started getting in halfway through and Mikhail built it and saw that it worked and everything, we kind of started looking into commercialized options because of all their data feedback that comes with it. For instance, the Whiting already has a software. We could build the physical part itself, but acquiring everything else that they have to offer, such as the administration, everything, we would have to do that ourselves. We would have to get our own generic card system and everything, whereas they already have it applied. But there is a cost and there is a reasoning for that, so it could still be explored.
Any other questions? Let's give them a hand.